Hi folks, we're going to take a look at number 12 from page 91 on the Unit 1 assignment. So they give us this function, which is a quadratic, and they want us to find the coefficients such that these conditions are met. So they tell us that the function passes through 219 and has a horizontal tangent at -1, -8. Now, because we're looking for three different unknowns, we need three different pieces of information to help solve this problem. And we have three pieces of information. So we've got a point on the curve. We know it has a horizontal tangent at this point, meaning the derivative at -1 needs to be equal to 0. And since it has a horizontal tangent at this point, well, it means that this point is also on the curve. All right. So let's start by finding the derivative so that we can use that in our solution here. So the derivative here, a is just a constant, so the derivative of x squared is 2x, so this can be written as 2ax, and then here b is just a constant, so derivative of x is 1, so plus b, and then of course the derivative of constant c is equal to 0. All right, so what we know is that f prime at -1 is equal to 0. So let's just input -1 here. So -1 times 2a, so -2a plus b has to be equal to 0. And what this tells us is that b is equal to 2a. All right? So we don't have the exact values, but we know this relationship exists. So when I'm working with the other parts of this problem, anytime I see a b, I can replace that by 2a. So that'll reduce the number of variables that I work with. So now let's use the other two pieces of information. So we know that it passes through 219. Okay, so now this is a point on the curve. So instead of working with the derivative, I'm going to be working with the function itself. All right, so when y is equal to 19, the x value is equal to 2. Okay, so what do we have? We have 2 squared, which is 4. So I have 4a plus b. But remember, b needs to be equal to 2a. So I'm going to make that substitution right away. And in this case here, x was equal to 2. All right. And then here we have plus c. So let's just simplify that a little bit and let's see what we get. Well, we get 19 is equal to, well, 4a plus 4a is 8a, okay, plus c. And what we have is an equation with these two unknowns. All right, so chances are we're going to need to solve a system of equations. So let's now use the other point on the curve, which is -1, -8. So when y is equal to -8, we can just replace x by -1. So -1 squared is +1. So this is just a. And then here we've got plus b, which remember is just 2a, times x, which is -1. All right, and then plus c. And now when we simplify this here, we have -8 equals a minus 2a is -a plus c. We now have our second equation with a and c. So if I call this equation 1 and 2, I'm not going to solve this system. Let me bring this underneath. So -8 equals -a plus c. And let's subtract these equations in order to eliminate c. So 19, this is going to be plus 8 is 27 equals 8a minus -a. So 8a plus a is 9a. And c minus c is 0, exactly as I expected. And so now I can solve for a. I see that a is just going to be equal to 3. So we have our first unknown. But remember that b was equal to 2a. So b is just equal to 2 times 3. So b is equal to 6. There we go. We have our second unknown. And now we can use one of these equations to find c. I guess I'll use equation 2. So what do we have? We have -8 is equal to, well, -a, so -3 plus c. So that means c is just equal to -8 plus 3 is -5. And there we have our three values that are going to satisfy these conditions. All right, so let's just do a recap here. First of all, is even before I start, I can already see that because I have three unknowns, I'm going to need 3 pieces of information, which they did provide for us. And then I just use those pieces of information to slowly chip away at these 3 unknowns. Now I'll give you a little tip. Because the derivative eliminates constant terms, because the derivative of a constant is always going to be equal to 0, it's often more useful to start with the information given by the derivative and then work with the information given by the full function. Because right off the bat, by taking the derivative of this function, I've eliminated one of my variables. Okay, so keep that in mind for when you're solving similar problems in the future. All right, that's it for this one.